Hi everyone, welcome to the PowerShell and Windows for Red Teamers course. In the second lesson, I will show you PowerShell fundamentals. PowerShell is a platform task automation solution comprised of command line shell. It can also be considered a script language and a configuration management framework. Nowadays, it can run on Windows, Linux, and macOS. Kind of PowerShell. Let's talk a little bit about PowerShell Desktop and Core Edition. PowerShell Desktop Edition is the classic PowerShell and is the most common one to use. It is installed by default on Windows and it's also based on the full .NET framework, which has all APIs, classes, and libraries. In our training, we will use the PowerShell Desktop Edition. To check which version you are using, just type PS Edition. For this case, the result is Desktop Edition. PowerShell Core Edition is a cross-platform automation and configuration tool framework based on .NET Core. The .NET Core is smaller than the full .NET framework because it's a subset of the full .NET. So, PowerShell Core has less functionality than PowerShell Desktop because it has a limited set of libraries. It's not installed by default, but you can have both installed on your computer. PowerShell Desktop and PowerShell Core can have the double coexistence. I will demonstrate how to install PowerShell Core Edition. First, we need to download it from your GitHub repository. Then, just install and click on Next, Next, Finish. And that's it. The PowerShell Core Edition is ready to be used. To confirm the version, just type PS Edition. The PowerShell Integrated Script Environment is a graphical user interface that we use to run commands and write, test, and debug PowerShell scripts. I will start the PowerShell eyes to do a simple test with write host. You must have seen that there are two types of PowerShell installed on the computer. One for 64-bit architecture and another for 32-bit architecture. I put two different directory paths side by side, but both have the PowerShell executable file. Another way to identify which PowerShell belongs to 32-bit or 64-bit architecture is to type a command as if it was a question. In this case, I'm asking if the PowerShell session I'm using is 64-bit, and the answer is true. I did the same command for the other PowerShell session, and the result is false. This is one of the ways to find out what PowerShell architecture is. The graphical user interface used to type command is not PowerShell. This blue window is a host process. PowerShell console and PowerShell.exe offer an effective instrumentation way to push the command typed by user at runtime, process the command, and deliver the result of processing to the host application, so that they can be returned to the user. In other words, PowerShell Runtime invokes by default System Management Automation DLL assembly to provide interaction between user and Windows system. You can get the assembly DLL by running the following command in PowerShell: ps object assembly location. Starting from host process concept, it's possible to use PowerShell scripts and command line without using powershell.exe to evade the endpoint protection. The name of this technique is better known as PowerShell without PowerShell. Other people call it unmanaged PowerShell. I'm going to do two different demonstrations of this technique. The first demonstration will use a tool that is published on GitHub called PowerShell as HDLL. The issue with this evasion method is importing a third-party tool and disabling Windows Defender. First, I need to install the Git SCM tool. This is necessary to clone the GitHub repository. The installation is simple. After the download, just click Next, Next, and Finish. You can also choose another method to import the repository. Now, we need to open the Git tool and make git clone. I cloned the PowerShell repository to the temp folder. And according to the documentation, it's necessary to call a native executable file from Windows. In this case, read svcs.exe and pass the powershell.exe file. If all the deployment and compiling steps were successful, we have conditions to run PowerShell commands without PowerShell.exe. Okay, the objective was achieved, but it was only possible because in this scenario, Windows Defender was disabled. Yes, but offensive and evasion techniques are always recycling old methods. You can take this tool and customize it to your needs, or research this concept and analyze payloads and try to identify similar techniques. What I'm trying to say is that your mindset as an ethical hacker should always be think outside the box. The second PowerShell without PowerShell or unmanaged PowerShell that I will demonstrate is related to a MITRE technique called indirect command execution. This technique relies on sync appv publishing server.vbs to launch PowerShell command lines from CMD, while remaining visible to Windows Defender. We need to open CMD and launch sync appv publishing server.vbs from your directory folder and pass a PowerShell command. Look, it was possible to bypass Windows Defender and running the script without powershell.exe. And so, we have conditions to perform a lot of post-exploitation steps in peace. Commandlets are native PowerShell commands. Normally, the commandlet is followed by a verb with a noun. Alias in PowerShell are nicknames for commandlets. The objective is to provide a familiar word to the user while typing PowerShell commands. To check the alias, just type alias-definition plus commandlet. Or get alias-definition plus commandlet. In offensive security, the real added value is to use alias to replace all commandlets to make analysis difficult. Window style parameter. This parameter allows us to control the window behavior when we run PowerShell commands. It's very common to see in the source code of the malicious artifacts that use PowerShell the window style parameter. This parameter has 4 possible values. Normal. No changes to the style of the current session. Minimized. The current session window will appear minimized. Maximized. The current session window will appear maximized. And hidden. No window of the current session will be displayed to the user. In this example, I will type getHost command to display the result in a maximized window. Command parameter. This parameter allows to perform the command or script file. This may seem obvious, but it's necessary when you pass PowerShell commands in CMD. PowerShell has a feature to facilitate navigation, which is tab completion. In other words, tab completion allows you to tab through available values you can pass to PowerShell commands. Tab-able resources allows to navigate available options for commandlet. Alias name, file system, registry, directory paths, and others. Look that in this example, I'm using the tab to autocomplete get help and get command. The pipe character allows to create a PowerShell pipeline. In short, this tells, hey PowerShell, take the output and use the pipe to pass it as input to another command. I will demonstrate an example in the next topic. Without going into a lot of detail on it, what you are looking in the output are objects. This is not plain text. I need to emphasize again, the outputs are not text. The outputs are objects. But if you need to get the content and convert the object data to strings, you can use the commandlet outString. I will show an example with getProcess. For this case, outString uses the string parameter to convert each object to a string rather than concatenate all the objects into a single string. The objects are sent down the pipeline and selectString uses the pattern parameter to find matches for the string when logon, like a grep in Linux system. When we work with offensive security, it's necessary to think outside the box. And there are some tasks we need to do, and the built-in PowerShell commands don't cover everything we need to do regarding pentesting. To solve this problem, we have conditions to import external PowerShell module to perform. The solution to this problem is to extend the PowerShell command set with external modules. To import, just use import-module, commandlet plus module name or module path. In this example, I will import the module called PS Diagnostics. I will type import-module-name PS Diagnostics. Done. The PowerShell module was imported. Now, I'm going to type a PowerShell command that belongs to the PS Diagnostic module. Get-log properties Windows PowerShell. No profile parameter. When we are interacting with a system, it's normal that it has environmental variables customized. And there is a possibility that it will bring problems in a PowerShell session. And to prevent environmental variables of the target system doesn't load the Windows PowerShell profile, it's necessary to use no profile parameter. In this example, I will run a simple command with the no profile parameter. Execution policy is a security strategy that Microsoft created to prevent the accidentally running of PowerShell commands, malicious code, or script. And there are some kind of values accepted in the execution policy. These values are All signed requires all scripts are digitally signed before execution by a trusted publisher. Bypass. All scripts or PowerShell commands are running without warnings. Default. Normally the status is remote signed, but it's controlled by Active Directory. Remote signed. Files and scripts developed locally don't require to be signed, but the artifact downloaded from the internet must be digitally signed by a trusted publisher. Restricted. Scripts can be run. Undefined. There is no execution policy defined in the current scope. Unrestricted. Similar to bypass, runs any script without restrictions. The most common to appear in malicious code is bypass. To check what is the execution policy are loaded in the current session, just type get execution policy. For this case, the policy is restricted. To get more information about execution policy, type get help space set execution policy at the PowerShell command prompt. There are few ways to bypass the execution policy. I will demonstrate some of them. To support the execution policy bypass, I'm going to create a simple script that, when run, will display the phrase "Hello World." The first try to bypass the execution policy is to set the current value to bypass parameter. In the last example, we saw that execution policy value was restricted. Look that it's not possible to run the script. For changing it to bypass value, just type set-execution policy bypass-force. But it only works in the elevated command prompt. Now we can see the policy has been changed to bypass and the script can run without errors. I will roll back the settings to restricted value. Second, an easy way to perform the bypass for a single PowerShell command is to pass the bypass parameter when running script. Take a look in this example regarding it. The script will be executed. Similar to the second example, I will change the execution policy level in a process scope. Let's check the current policy. The process scope has undefined policy. I need to change it. I will type set execution policy bypass -scope process. Take a look again in the current policy. it's possible to see that process has a bypass policy. Let's run our script. Look that a bypass was performed, but it only works for a current session. If I open other PowerShell window, the same command not works because this session don't has a bypass process scope. Fourth, running a script or PowerShell command and combining with pipe. I will open a new PowerShell window and type echo get host pipe PowerShell space dash and done. Fifth, we can read the PowerShell script with getContent commandlet or type and pipe it into PowerShell. Look, if I type getContent plus script and pass the pipe with PowerShell dash no profile space dash, it's possible to see the result. Sixth, other way to bypass is disabling the authorization manager. This technique changes the authorization manager to null, being possible to bypass the PowerShell session. For that, I will copy and paste an extensive command in the PowerShell window. Don't worry, all commands used in the course are available in the student support documents. Now we can do any command because there are no restrictions. But it only works for a current session. If I try the same in other session, it's not possible to run the script. Seventh and eighth, it's possible to bypass using encoded command and invoke expression commandlet, but I will demonstrate both techniques in the next topic. PowerShell base64 command. There are situations where we need to encode a PowerShell command with the intention of obfuscating or confusing the antivirus, and for those cases, we can use the PowerShell encoding techniques. In the first example, I will show how to convert the getHost command to base64. To analyze the command that I put, it's necessary to read it backwards, like little end concept. I am informing the command that I want to encode, and then it will collect the Unicode representation in bytes of this command. And next, I will pass it as a text to convert to a base64 string. This will give the base64 string. In the second example, I will run the encoded command. For that, I will type PowerShell-encoded command with encoded string. And now we can see the clear text output. So, in the third example, I will do the inverse operation to decode the base64 string. I will pass the encoded text, and then it will collect the base60 for the string. And next, the string will be decoded. Let's run. And so, the original command is displayed. Invoke expression appears very often in malicious artifacts and offensive security activities. Take a look in this behavior. I will type a simple command, dir to list the content folder. But if I put dir command in quotations, the output is the command name and not your result. When I use invoke expression, the behavior is different because we call it as a string to execute as a command. Bringing invoke expression to execution policy scenario. Remember that our current execution policy is restricted. But if I run the script with invoke expression, the content will be running, because we're calling the script to read the content as a string and capturing the output to execute as a PowerShell command. And with that, we close the second module. Until next lesson.